Okay. Some brief announcement first. Notice that the labs are common to all the sections. So far you got lab 0 and lab 1.1. There'll be 2 parts to lab 1. But for this week's lab 0 and lab 1.1, it will be this afternoon. We got 2 sessions for the lab. Make sure you go to the one you register. I'll try to be there at least for the first hour. So if you got other questions to ask me, please do come by. I'll be there. Okay, lab session today, I'll be there. And remember, I sent out some study advice for you last Friday. So week number 1, which will end today, we are mainly just going to review what we covered back in 1022. Today, I'll try to cover some more tricky example, and at the same time, I'll review some basic concept with you. But starting from Wednesday, we will cover new stuff. Okay, Wednesday. But for today, we'll still review classes and objects. And we'll see some new examples, which you didn't see in 1022. That will be fun. Okay, any questions for me? And also one more thing, for the GitHub. Setting up the GitHub account is optional for this course, but I will highly recommend you try because it's quite a good practice to manage your software rather than just putting them on Dropbox or Google Drive. It's a much better way to manage. But I did add more videos to it over the weekend. Go over them. If you got any questions about GitHub, let me know. Okay, but it's highly recommended. Okay, so let's go to Eclipse first. I would like to start from there. So last time we created a class called person and also a test called person tester, right? So what I would like to do today, I would like to show you first of all some very cool features in Eclipse, which is so-called a code generation. They can generate certain code for you if you already got certain starting code for yourself. Okay? Let's now, first of all, focus on the person class. Let's see what we have got from last time. Remember, we got age, we got weights, and we got heights. So we got 3 attributes over here. Remember, we always talk about setters and getters. Let's just talk about for age. Let's say I want to have a mutator who has got return type void and set age. What would be the implementation for set age? Well, I should take an age input and say this.age is assigned to age, right? And what about the mutator for weights? Let's say void set weights. Something very similar. This.weight is assigned to weight. So this kind of a routine business can be automated in Eclipse for your convenience. I'll just show you quickly how you can do it. Of course, this is only for the very basic setters and getters you can generate automatically. This might save you some time for your lab assignments or for your lab test. Okay. What you got to do is select the attributes from which you would like to generate the getters and setters in Eclipse, and then right-click on the portion you just selected, and go to an option called source. And over there, okay, let me go back again. Source, and under which you have something called generate getters and setters. Okay? Choose that one over there. And then there's a panel brought up over here. You can see we got age, we have height, and we have weights. And there are certain boxes you can check. But before we do anything, expand the triangle over here. You will see get age and set age. So that means it assumes you simply just want to generate some standard getters and setters. Okay? So what I can do, I'll show you all of them. So what I can do, let's close the triangle here. I'll simply check the 3 boxes over here. So which means the setters and getters will be generated for each of the 3 attributes. And then, so where should I insert these methods? So at the moment, the person constructor, as you can see, starting from line number 19, that's kind of the endpoint of my class. Let's insert after that. So what you can do is after the person constructor over here, and I can just say generates, and done. That's done for you. Okay, that's something really cool you can actually try to use. And notice that there's something I would like to point out. Have a look at this method here, let's say, set weights. Line number 37, you can see there is the use of this keyword. Okay? Line number 37, and also you can see line number 33 over here. For weights, there is no use of this. Can somebody explain to me quickly why it is necessary to put this in line number 37, but in line number 33, it is not necessary to do so, even though you could put it, but it's not necessary. Yes, go ahead.
Because in the method line 26, you have the parameter weight already has the same name as the
Brilliant. That's exactly correct. Let me just rephrase what you just said. That's exactly correct. So let me just mention this briefly for this keyword, just like a review. You can also see the relevant topics discussion in my slides. Now, if you look at over here in line number 33, it's in the context of this class. You can see that when I talk about weights over here, there is no parameter, there's no inputs for this particular accessor. So the weight over here has no choice. It must refer to the weights over here as the attributes. That's case number one, right? That is why in 33 over here, you don't have to mention this, even though you could. If you do this weights, it means something the same, equivalence, but you don't have to. Okay, that's the first explanation I would like to put. On the other hand, if you look at line number 37, which is in the context of this class over here, this method here. Let me use iPad to illustrate to you very quickly. Okay. So now remember, we are now in the context of the person class. And remember, in the person class, we have an attribute of type double and weights. And we have this mutator here, void set weights. And usually, you don't really want to just come up with new name. You can simply just use the same name as the attributes. Okay? And over here, right? Over here, if you say, okay, just before that, you can notice that we have potentially some name clash over here, weights and weights. They have the same name, which means when you refer to weights over here, if you simply say weights is assigned to weights. Anybody remember I talked about this phenomenon over here? So what this really means is not to assign the weights into this weights. It actually means to assign the weights to itself. There's a word for this. Not aliasing. We'll talk about aliasing, but it's totally different. It's redundant? No, not redundant. Well, even though it's redundant. Yes. Shadowing. Brilliant. Thank you. So it's called shadowing. You can see over here, the weights over here, let me just highlight it for you. So you can see the weights over here, it's called shadowing. Let me just write it out. It's called shadow. So basically, it shadows this weight over here. So when you talk about this weight here, it's really referring to this weight here. Okay, so this is not exactly what you intend to do. In this case, what you can do is you can try to contextualize the weights over here. So the way to do it would be, let me just write it out. So you would say this dot weights is assigned to weights. Okay, so this line should be put instead. So the consequence of this is, because now when you have this dot weights, this means the context objects, but I will illustrate this exactly to you in a later example. But this over here means we're talking about a current class, the current objects when you are in the context of some method call. So this dot weight refer to this weight over here. On the other hand, you can see that, let me use a different color here. When you have weights over here, it refer to the parameter weights here. Okay, that's something to note. Again, it's a review. Any questions about this? Okay, and you will see that this keyword over here is rather useful, especially if you want to trace method calls in complicated example, which I will show you today towards the end. Okay. Okay, if no questions, I would like to go back to Eclipse just to say, so what we have shown you was, so these are the setters and getters you can generate based on the attributes in Eclipse. And you can definitely give it a try, okay? It might be useful for your projects, okay? And I would like to go back to the slides, and I will talk briefly about methods, just review them quickly. Okay. By the way, guys, when you see the slides over on the web, so Aliasing logo over here is a hyperlink. If you click on that, you can go to the index for the slides. Okay, in case you haven't noticed that, just helps you explore the slides better. So I would like to go to the methods over here. Let's just review. Okay, so what's really a method? So in object-oriented programming, so there are two important concepts you have to know. Okay, let me just mention them over here. Okay. Of course, you have, let me just add a new page over here. So when we talk about OOP, so there are many things that are important. So now we have class, and under the class we got attributes, and we have methods. Okay, so this is more like at a compile time, which means when you're trying to program your Java classes, compile time. Okay, at the runtime, you have objects, and that's more at the runtime, which means as soon as you execute your Java class, you're going to execute your code line by line. At the runtime, you have objects, and also more specifically, you have context objects. And also you have method call. Okay, I will explain these concepts a little bit more in the examples, but I just want to mention them first. So these are the things you should really bear in mind. They are very important. You will just keep using them throughout the course. Okay, so now let's go back here. So method is simply just conceptually just a block of code. And for anyone who wants to use your Java classes, they don't necessarily have to know how you actually implement your method. For example, remember back in 1022, so we talked about how you can use the array list, hash table, and some other API, right? So briefly, you didn't have to know how they implemented the array list or hash table. You simply use the method. So to you, the method is simply just like a black box, right? So it's completely hidden from you. Okay, so now there's something I would like to clarify to be more precise. So there is a distinction between the header and signature of a method, which I would like to talk about now. Okay, it's very easy to see. Okay, so now again, let me just use another new page here. Okay, so now let me just give you one example. Let's say in the person class, we have void set weights. And then we have double weights. Okay, and then we have some implementation over here, right? So this part is called the implementation of your method. Okay, let's try to clarify the terminology first. Okay, first of all, we know that this guy here, this void over here is called a return type. In the case of the mutated method, the return type is simply just void. And in the case of accessor method, it can be double, can be even a person, or it can be a point array, right? It can be anything. And of course, this is the name of the method. The name of your method. Okay, and this one over here, okay, so this is basically the first input or parameter. Whenever you're trying to define your method, you have to put parameter. When you actually give some specific value for the parameter, it's called arguments, which we'll show you in just a moment. Okay, and double over here is called the parameter type. And the weights over here is called the parameter name. Okay, and of course, you may have first parameter, comma, second parameter, comma, third parameter, as many as you like. Okay. Now, I want to talk about the distinction between header versus signature. Okay, it's basically just definition. I just want to show you. Okay, so now, first of all, if you talk about the whole thing over here, return type, name of method, and all the parameters together, just the whole thing, without the implementation, this is so-called the header of the method, the whole thing, the header. And a part of that, except for the return type, is called signature. So what do I mean? I mean something like this. Let me just use green maybe. So when you have the name of the method and the parameter and types, except for the return type, this is so-called the signature. Okay. It's very subtle difference between header and signature. But informally, if you really got mixed with these two concepts, that's okay. But I would say just to be formal. Okay? One is called header, one is called signature. Okay? But basically, the two terms are mainly just to refer to the information for the methods. What's the return type, what's the input type, and what's the name of the method. Okay? Just a quick distinction. Okay? Okay, let's go back to the slides over here. And then we have return type. Okay, you can read them. Okay? Okay, in the body of the method, so these are simply just to say whenever you have, let's say again, over here, let me just go back to where I want to. Let's have a look at over here, not this one here. If you look at the class over here, okay, for the person class, let's just go very quickly. So you can see that over here we have the accessor get BMI, and we have the mutator gain weights by, right? One returns void, the other one returns double. Okay. So what can you actually use inside the methods? There are two kinds of things you can use. You can either use a local variable, or you can use the attributes. So now in the case of get BMI method, you see both cases. Okay, I'll show you. So now over here, you can see that, first of all, the BMI over here is newly declared. So this is simply a local variable. So that means the scope of this variable is only within this particular method. If you try to refer to BMI, let's say in gain weights by method here, it simply wouldn't compile because the scope is only limited to get BMI method here. Okay, that's about local variable to the method. Okay. On the other hand, you can see over here we are referring to this dot weights over here, this dot weights. So this is more like a class-wide variable, they are attributes. So this dot weights refers to the weights over here, right? So this is more like class level variable. Okay, so these are the two kinds of variables you typically use inside the method to perform your computation, right? Either local or attributes. Okay. Any questions until now? I hope that's just basic. Just bear with me for one more lecture about the basics, but we'll do more tricky example towards the end. Okay, you can read it through. Okay. Okay, so this is just to make things a little bit more formal, but I'm just one thing to note over here. Let's compare the example over there, the last line. Jim.getOlder versus Jonathan.getOlder. If you only look at these two expressions here, you can see that they are trying to call the same method, getOlder, the same method. However, the effects, when I say effect, I mean the return value from this particular accessor here might be different. How can they be different? It depends on what the context object is. On the left-hand side, you can see the context object is Jim. Jim presumably is a person object, which may have the age 53, for example. On the right-hand side, the context object is just another person object, Jonathan, in which case he may or may not be 53. He might be maybe 65, right? So the context object is very important for you to decide how the method call is going to be executed. And we'll see example in just a moment. Okay, okay, that's about the method here. Okay, and then let me just go over again. So last time I mentioned about the three kinds of methods in Java. So you can either have constructor just for you to initialize the attributes, right? And then that's how you always, if you have the new keyword and use the class name, so that's a calling the constructor. Okay, and I will try to visualize how each call to particular method will look like. We'll do that in just a moment. And mutator. The general principle is you don't really want to mix mutator with accessor. You want to have a very clean purpose for your method. So the mutator usually just changes the attribute value. For example, gain weights by, right? You want to change the weight value. On the other hand, you also get accessor. Accessor is simply just based on the values for the attributes. I want to return something based on some computation on the attributes, right? So these are the, and of course, at the end of the method, typically you just have a return statements. Okay, that's something hopefully just basic for you. Okay, any questions until now? Okay, and I would like to jump to one part of the slides, which is called visualizing the object creation at the runtime, and then I'll start from there, and then I'll use iPad to illustrate to you how things should work. So I want you to pay this part of the slide very carefully, because as we go on with the rest of the course, usually when we show you any sophisticated Java programs, there might be quite many threads of manipulating the objects, in which case you really want to trace your program by drawing some diagram, which especially when you have aliasing in your program, you definitely have to visualize your objects. Okay? So I will use some simple example to show you first. Okay, and you definitely can read it over here, but I'm gonna just show on the iPad. It's exactly the same stuff, just more would be clearer to you if I use the iPad. Okay, but so these are basically the rules I'm gonna use. You're gonna draw some rectangle box and the title of the attribute, left column and right column. So read through the rules. It's just a very systematic way of tracing your Java program. Okay, let's do it together. Okay, now let's go back to this program over here. So we already have seen the two methods, and also we have person over here, and we have three attributes in the person class. We have, let me just use different color here. We have age, we have nationality, we have weights, and we have heights. So these are the four attributes for the person class, which means each person object at the runtime is going to possess values for these four attributes. No exception, right? It's going to be the same for all the objects. And that's the constructor and accessor and mutator, right? Okay, so now I would like to trace this block of code for you. Could you please just have a look? Just spend 10 seconds on the code, just to roughly get what it's doing, and then I'll visualize them for you. So this is a simple example to begin with, just to warm up. Okay, okay, let's try. Let's see how we can trace it line by line. Let's start with this line here. So first of all, we're going to see the new keyword over here. How about this one here? What is that going to do? What it is going to do is referring to the constructor of the person class, which is defined over here, right? And there you can see that over here. Let me just make some example here for you. You can see, for example, the string value British over here is passed as the second argument value. Second arguments value. And it is going to be used to replace the second parameter over here, right? You can see the second parameter over here is the string n, right? So this is the second parameter. Okay? So what does that mean? Okay, let me start drawing diagram for you, and then I will show you exactly how the substitution is going to be made. So this applies to all the method calls, including object creation. So let's see this. I want to talk about how is this new object going to be created. Since we want to create a new object for person, so what we're going to do is we're going to draw a box over here at the runtime. So now we already talked about runtime. Okay, and then we're going to draw a box to represent the objects of type person. Okay, you put a person over here simply because we are talking about person type objects, right? And then how many sections should we have for this particular box? 4. How do I know that? Because we got 4 attributes over here, right? Let's do it. Okay, so I'm going to put over here, let me just divide that into 4 sections over here. Okay, and age, nationality, weights, and heights. Like that. Okay, so these are the 4 attributes, which means every person have these 4 sections. However, the right column over here, let me just make some more annotation for you. So this column over here contains the attributes. And this column over here contains the attribute values. Attribute values. So now the question is, we got 50, British, 80, and 1.8. How do we actually do it? How do we do it, right? So now since we have already created this object over here, so this is now the context objects. So this is now the context object for this particular constructor call over here. That's the context objects. So now when we have a look at this, let me try to use a different color here. You can see the first parameter value is 50. That means we're going to apply the definition for this constructor over here, replace every occurrence of A by 50. 50 here, and then replace A over here by 50. Okay, and that's it. So 2 occurrences. So what's the consequence? The consequence is, if you look at this line, when you say this dot h is assigned to 50, so what about this? What's this? Well, this is simply this object we just created. Remember I said there's a context object. Since now we talk about creating a new person object. So that one is this. Okay, and then when we say this.h is referring to this field over here. That is assigned to 50. So we're going to assign 50 over here. Okay, any questions about this? Okay, it's really important for you to see how this can be traced. Okay, okay, similarly, we're going to execute the rest of the lines over here. So I'll leave them to you. So eventually what you will get is, so this part, of course, will be British. And this part over here will be 80, and this part here will be 1.8. Okay, let me just put it here. British, 80, and 1.8. Okay, so that's it. And then, so that's about this part, new person. We're just creating an object at the memory, at the runtime. So now, what about the left-hand side for the assignment over here, person Jim? That means we are declaring a variable called Jim. And Jim is going to store the address of some person objects. In this case, because we have the assignment equal sign over here, that means we're going to store the address of this person object here into Jim. And remember what I said at the end of the lecture last time. You can conceptually just draw an arrow like that, which means Jim points to person. Right? It doesn't store the entire object. It stores just the address. Okay? So that's how you trace the very first line. Any questions? Yes?
Just looking forward a little bit, the last line of the code.
We'll get there. How about that? Okay, good. It's good that you look ahead, but let's wait for the rest of the class. Okay, good. Okay, second line. Okay, the second line over here, I'll make it a little bit briefer for you because for the first one, you kind of get an idea for how to use this. So second line here, we say double BMI is assigned to Jim.getBMI. So now look at this. When you say Jim.getBMI, every time you talk about method call in Java or any object-oriented programming language, the context object is very important because Jim over here is the context objects. So what does that mean? That means when you want to get BMI, you have to apply to certain person objects. But at this point, when you say dot, okay, let me just put it here. When you say Jim.get BMI over here, again, this part over here is the context objects. Okay? Now, the dot over here simply tells you, look at the address that is stored in Jim. Go to the memory location accordingly, and then apply the effects of the method. That's what it means. Okay? So now, let me just write it down for you. So the dot over here means look up the memory location according to the address stored in Jim. Okay? And that will actually bring you to this object here, of course. Okay, let's go on. And then you can see that we are trying to call the getBMI method, which is defined over here, right? getBMI. Now, what should happen is every occurrence of this in the method definition is going to be replaced by the context object. Again, substitution is really important. So now in this case, you can see that this over here is going to be replaced by Jim, right? Over here. So that means double BMI is going to be Jim.weights divided by Jim.heights multiply Jim.height. That's how we calculate the BMI, right? So that means Jim over here, we got the weights and heights, 80 and 1.8. You'll be calculated accordingly, whatever value it is. Okay? Any question here? Let me put something aside just for you to compare. What if I put another line over here? Can we just imagine hypothetically? I put it here. We got double BMI. It's assigned to, actually I want to put 2 extra lines. Let's say BMI 2, okay? And then let's say I insert one line over here after the double BMI. I also insert another line over here, okay? So I would say person, let's say Alan. It's assigned to new person. And then maybe I'll put 45 years old, maybe Canadian. Maybe I'll put 75, and then 1.7, something like that, okay? And then when I say double BMI 2, it's going to be Alan dot get BMI. So these are the two extra lines I'm putting, okay? I'm trying to show you, okay? So now, we can see that for this particular line over here, person Alan is equal to is assigned to new person. What it will do is it's going to just create a new box. I'll just draw it very quickly here. So basically, Alan is now. Let me use a different color here. So Alan is now going to point to a person box over here. Okay. For simplicity, I'm just going to omit the sections over there, right? But Alan's box is also going to have A, N, W, and H. But the values for them will be different. It's going to be 45 Canadian, 75, and 1.7. Okay? So now, what's really critical is to look at this. We are trying to call the same method here, get BMI. I want you to compare these two lines. So Alan.getBMI versus Jim.getBMI over here. You can see we are trying to call the same method, get BMI, but the context object is different. You can see the context object over here is Alan. And the context object over here is Jim. So that means to apply the get BMI method, we have to apply to different objects. In this case over here, Alan.get BMI, we have to look up this particular objects over here, right? And then we're gonna apply to the same method here, get BMI, but now this is going to be replaced by Alan instead, rather than Jim, right, as before. And this is now going to be Alan.heights and also Alan.heights. You can see the same method might be applied differently depending on the context objects. That's my point. So these two lines will give you two different results. Okay, any questions about this? Okay, quite many basic things just about context objects and how you can call methods. Okay, let's just go to the next line here. Okay, third line, when I say Jim.gain weight, again, since the context object is Jim, that means I'm calling the mutated method to modify certain attribute value for this particular object. So that means I want to modify the object pointed to by Jim, right? I'm gonna gain weights by. So gain weights by is over here. It will simply do as follows. You can see Jim is a context object. That means every occurrence of this is going to be replaced by Jim, right? And then we're gonna update Jim's weights from 80 into 80 plus 10. So that'll be 90, right? And then finally, over here, maybe that's what you were talking about. It should be Jim. Yeah. Yes, thank you. Okay, that should be Jim, that's a typo. Of course, if you simply type this, it wouldn't compile. Okay, so BMI is reassigned to Jim.getBMI. In this case, we're talking about Jim, the same object over here, but now the weights and heights will be a different computation here, right? It's going to be 90 divided by 1.8 square, rather than 80 divided by 1.8 square, right? It's different. So you can see that again. Let me just use one more highlights. So this line over here and this line over here, so they are going to give you different results, simply because in between, you try to change the weights by adding 10 to it. Okay? Any questions about this? Are we okay? Okay. Guys, if you really got questions, please do raise your hands now before I go on. Okay? I assume that's just basics, right? Yes, go ahead.
Okay, I'm just going to ask a quick question. So
Yeah.
In the second line, so basically you've written the fourth line and instead of the second line, and let's say the third line wasn't there in the tester code, we'll still get the same thing, pretty much.
You're talking about, okay, I'm not sure if I understood your question here. So you're talking about, are you referring to this line here? You were asking if we didn't have this line over here, right? Okay, good question. The question was, what if, for now, I simply delete this line? Let's say simply delete this line. Will the result of this be the same as the result of that? Yes, right? It will be, Because that means you try to have two consecutive calls to the same objects without changing that. So the first call to it, gym.getBMI, you're simply going to apply 80 divided by 1.8 squared. And then you jump to the next line, gym.getBMI again. Of course, you apply the same formula to the same numbers, right? So it really depends on whether you change the attribute values in between. It's important to see, right? Okay. That's about visualizing the object, but it's only a single object, right? And what's really fun about OOP is when you have multiple objects together, and remember each reference variables only store the address. You may copy address around, and that's going to cause a phenomenon called aliasing at the runtime. So that's where things can get interesting, okay? Why don't we have a look at some example, okay? Let's have a look. So I'm going to talk about aliasing. Okay, can I move on from this topic? Any other questions? I assume everybody's okay. Okay, let's now have a look at aliasing. Let me just talk about aliasing again. I do have some new examples for you, but let me just talk about the basics first, just to explain what the issues is. And then we'll see some new examples. Okay, so now I would like to compare basically reference types versus primitive types. Let me just add a new page on iPad, and then I will move on to there. Okay, let's have a look here. Let's just start from the basics, okay? When you talk about line number 1, integer I is assigned to 3. How do you visualize this? You can see int is not a class name. It's simply a primitive type, right? So that means it's not going to be about the address. It's just about the value itself, okay? So how do we visualize this? We'll simply say I is going to store the value 3. That's how you visualize that, as simple as that. There's no address, no memory. Well, there's no arrow. That's what I meant. There's no arrow like what we drew for the objects. And then we say j is assigned to I. So now in this case, you can see that int j is assigned to I. That means we are simply creating a new variable, like a new box for j. And now how do we visualize that? Basically, when j is assigned to I, copy the value in I, and put it into j. So now we got 2 copies of the same value, 3 and 3. So now intuition is, if you try to modify the value in j, it is not going to affect the value for I, right? Because they're completely separate copies, okay? That's kind of the idea. Okay, let's have a look. And now if you say I is assigned is equal to j, equals j, just compare the value, that should be true, okay? That's easy. And then when you say k is assigned to 3, okay? In that case, k over here is assigned to 3, just a separate copy. So now we got 3 copies of the same value, okay? I want you, this is really basic, but I do want you to watch the pattern I'm copying the values, because the way we figure out how things work for references is very similar. It's just that we move to values of addresses. Okay, now if you say k is equal to I and k is equal to j, right? You'll be just true, right? No question about it, easy. Okay, about that. Now let's have a look at this. Let's now try to see how things might go a little bit differently here, okay? And then we'll see some interesting example, okay? Now, let's assume that we got a point class and we got x and y over there, and then also we got a constructor which will initialize the x and y coordinates. So now, how do we visualize line number 1? When we say P1 is assigned to the address of the new objects with x being 2 and y being 3. How do we visualize that? Let's try. So the way to do that would be P1 is now going to store the address of a point objects. And let's assume every point class has the every point object has the 2 attributes. Let's say x and y. Right? In this case, we're going to have 2 and 3. Okay? 2 and 3. So far, so good. One more thing to emphasize over here. So P1 over here stores address of a points, objects. Again, I want to emphasize that. Number 2, when I say point P2 is assigned to P1, now, what does that mean? Well, if you just try to interpret that literally, we're trying to copy values, right? But now the value we're trying to copy, unlike in the previous case, we simply copy 3 into some primitive variable. Now we're copying the address, right? Because remember, P1 stores the address of some person objects. And now we are copying that address to some other variable, which means the consequence will be, after line number 2, P1 and P2 store the same address, referring to the same objects. Okay? Let me emphasize that on the iPad over here. If you look at that, over here, if I say P1, point P2 is assigned to P1. Okay, if I say that. So that means copy the address of P1 and put it in P2, right? So now how do you draw the diagram then? Well, P2 is simply some address holder. So now P2 is going to store the same address as P1. That means it will point to the same objects. Don't you agree? So now what's interesting now is like this. It's so-called aliasing. Aliasing in the sense that the same objects for point over there has 2 names. One name is P1. The other name is P2. And now in order for me to change the objects for the point over here, I can use either name. I can use P1 to change it, or I can use P2 to change it. Let me show it to you. Okay? I want you to create some code on the fly over here. So now let's say this. If I say system.out.println, can I just put P1.x plus a space plus P1.y? Okay, just this line here. What's going to be the output in this case? 2, 3, right? 2, 3, right? P1.x, P1, and go to the memory location, .x will be 2, .y will be 3, right? So the output will simply just be 2 and 3. I'll put it like that, okay? So now I'm going to show you what aliasing really means in a simple case. I'm going to have a line over here. I'm going to say P2, which is a different name from P1, even though they point to the same objects. I'm going to say P2 dot move up by 3 units. Let's also assume we also got a mutated method called move up in the point class, which will increment the value for the y, right? That's how you move up in the 2-dimensional plane. Okay? So now when I say P2 dot move up, which object should we change? Well, this object here, right? P2 is referring to this point object over there, and that P2 is a context object. And then we say move up. So that means change that from 3 to 6. All right? So now I would like to copy, let me do it again. I would just like to copy this line over here, and if I can paste that easily, let's see. Paste it over here. The same line. Is it going to give me the same result as before or not? Is it going to give me 2, 3? Not at all. Why? Well, I can argue that the 2 blue lines are exactly the same. The red line is using a different name to change the value of the object. Why should it affect P1? That's my argument. Anybody want to challenge me? Yes?
They're both pointing to the same address. So the second you call P1 point class again, then it's...
Yeah. So just want to correct you one minor point. When you say they point to the same address, they point to the same objects because they store the same address. Okay, minor point. Okay, good. That's exactly correct. So over here, you can see that the 2 blue lines here are exactly the same using P1. And the red line over there is trying to change the point object using P2. But in this case, because P1 and P2 refer to the same objects, so this line over here is as if you actually said P1 dot move up, just as if. Okay, the same effects. That's aliasing. Aliasing is as if you said P1 dot move up, and then pass 3 over here. Okay, guys, any question about this before I show you some interesting example? Okay, it's still early in the class, so I can still have your engagement for that interesting example. I got 2 examples for you. I'll do the second one first, maybe, and the first one is a little bit tricky, so I'll leave the tricky one a little bit later. Yeah. They do refer to the same object. Okay, it's a very good question. The question was, after the second blue line, do P1 and P2 still refer to the same objects? The answer is yes, because we haven't really reassigned P1 and P2 to any other objects. But that's exactly what the interesting example I will show you. So you can see that aliasing is simply there. It's a very natural consequence of the reference variable storing addresses for objects. It's a very natural consequence. So that means you have to pay extra attention to it. So now let's do one example together. And for those of you who took 1022 with me, you haven't seen this one yet. Okay? Let's do it together. Anyone who's a fan of Tom Cruise? Anyone? You might hate me after this example, but we'll see. But forgive me, okay? Okay, I'll do this one a little bit later, okay? Guys, have a piece of paper, if you have one, and have your pen. I will do it together with you. It's a very nice exercise for you. Get it ready. We'll start in 30 seconds. Just get your paper ready. There will be about 4 or 5 questions at the end. I'm going to randomly pick somebody to answer. So please, do participate. Okay? Okay, just another 10 seconds and we'll do it together. Ready? Okay, let's go. Now, first line. Can you visualize this line here? Oh, again, we have a person class, and let's say each person let's make it simple. Person class, each person has a name and has a weights. Name and weights only 2 attributes. Let's make it simple. And how would you visualize this line? I'll draw on my iPad, and then we'll match. Try to be as precise as possible. You can just use M for name and also W for weights. That's fine. Okay, that's something you should get. Why 0? Well, because over here, I'm assuming that for the constructor here, it only initializes the name attributes. But for the weight, simply default value. Okay, no default value for a person. No default value for the weights for the person. You got to set it explicitly using the mutator. Okay, next line. Person Ethan Hunt is assigned to Tom. You guys have watched MI6, I suppose? A little bit? Oh, it's a good movie. It's a good movie. Anyway. Okay, I'm going to draw that as well. So this is what you should get, right? So now the same object has 2 names, Tom Cruise and Ethan Hunt. Make sense? Okay. Anybody who has already lost, please do let me know before I go on. Okay. All right, that's about the second line. Third line. Person spy is assigned to Ethan Hunt. So what does that really mean? You can see that we got three names already. We got Tom, we have Ethan Hunt, we have spy. First of all of them have the same type, person, which means each one of them is going to store the address of some person, right? But now, do they refer to the same person though? Do they? How do you know if they refer to the same person, right? You can see that over here. Well, how do we read this line here? Copy whatever address that is in Ethan Hunt, copy that to spy. How do we get an Ethan Hunt address? Ethan Hunt was copied from Tom. So that means the original address, which is Tom over here, from the new object there, it was copied twice, right? First of all, it was copied from Tom into Ethan Hunt, and then from Ethan Hunt into spy. So 3 copies of the same address. So what you should get is like that. Oh, sorry, I forgot to finish that. All right, aliasing. So now that means if I want to change this object here, I can use either of the 3 names, right? Pretty much like a P1 and P2 before, okay? Any questions? Good? Okay. Let's do some boring manipulation first, and then we'll see the interesting one. So now, when I say Tom does set weights 77, how should we change? Okay, I hope this is something you will get. And the reason that I emphasized Tom was because you can see Tom over here was the context object for set weights, right? And then I want to set the object's weights attribute to be 77. At the same time, let's say after this line, if I try to call Ethan Hunt.weights, what would that be? 77, because I'm talking about the same object here, right? And spy.weights, 77, right? So far so good? Okay, let's go on. Okay, of course, Tom.weight would be 77. Now, let's say this. Ethan Hunt.gain weights, 10. What's going to happen? Well, apparently, we're going to change the weight of some object, right? But now we talk about Ethan Hunt, not Tom or spy, right? Okay, try to make some annotation on your diagram, and then I'm going to annotate my iPad as well. Okay, after that, hopefully that's something you will get, right? So now we're using the context object Ethan Hunt, but now the same object is being pointed to by Ethan Hunt, right? So now 77 becomes 87, the same object. So now if I try Tom.weights, 87 rather than 77, because the same object has been changed. So that's why drawing diagrams is really important. Imagine if I put this on the test or exam, how would you trace it? Unless you're really, really confident, otherwise you want to draw a diagram like what I'm doing now. Okay? It's really important technique to pick up. Okay, now if I say Ethan, oh, that's what I say, right? Okay, Ethan Hunt.gain weights, and Tom.weights would be 87, as we said. Okay, what about once more? What about spy.lose weights? 77, right? You can see what I'm playing, right? I'm just using different name to change the same object. That's exactly what aliasing will give to you. Okay, spy.lose weight. I'm going to use different color on my iPad. Spy.lose weight. Okay, that's something we'll get. So now this time, spy was the context object, and change the same object's attribute value from 87 to 77, right? The same. So far, so good. Okay, now, okay, Tom.weights would be 77. Let's introduce myself to the picture. How would you draw this? Okay. Huh? It's a new rectangle, I agree, because it's a new object, right? Because you see the new keyword there, draw it, and then we'll see if you got something that matches my diagram. Oh, so you can just draw the diagram after executing these two. Okay, prof.setWeights after that. Okay. Okay, that's something you should get. Yes? Okay, different objects. And you can see the aliasing only occur for this particular object here, only this one. But for this object here, myself, right, it's only one name, just prof. Okay, so far. Now, let's try something here. I would like you to think about how you will make the following changes. Spy is assigned to prof. Prof is assigned to Tom. Tom is assigned to spy. Try this and pollute your diagram. That's okay. Try this, and we'll do it together in just a moment. So you can see that, right? The order of assignments and the order of putting the left-hand side and the right-hand side is really crucial. Okay? It looks a little bit like a circular, but it's not the point. The point is follow faithfully what the assignment asks you to do. Imagine you are the computer. Okay? And see how the diagram would look like. And I'll do it together with you. Okay? I wouldn't just show you the final diagram. It's not fun. Okay, let's do the first one. When we say spy is assigned to prof, okay, let me ask you this. When I say spy, let me put it here. Spy is assigned to prof, right? How should I change the arrow? Am I trying to say something like this? Prof, rather than pointing to this object here, is going to point to wherever spy is pointing to. No? Yes? No, right? Good, good. That was intentional, right? Okay, apparently not. Again, copy the address of prof and let spy store the same address. That means spy, rather than pointing to here, pointing to here. So now I'm a spy. Okay? Now, what about the next one? Prof is assigned to Tom. Prof is assigned to Tom over here. Okay, so hopefully now you can do the right thing, right? So now that means prof, rather than pointing to, maybe use a different color so when you review the notes, it'll be easier. So now prof is assigned to Tom. So now prof, rather than pointing to this object here, is going to point to wherever Tom is pointing to, right? That's the one. And then the next one, Tom is assigned to spy. Okay, let me use, what about green? Tom is assigned to spy, which means Tom, rather than pointing to this object here, is going to point to wherever spy is currently pointing to. Spy used to point to this person over here, used to, but not anymore, right? So that means Tom is going to point to, you know what? If this makes sense to you. Okay, like that. You can see how the things are being manipulated. Okay, that's about it. And now let's answer questions. Okay, let me point one by one. Okay. Okay, now the first one, prof.name teaches 2030. Anyone? Anyone? Yes. Tom Cruise teaches 2030. Okay, anybody want to try the second one? Yes. Ethan Hunt is Tom Cruise. Okay. Third one. Okay, yeah. No, I want somebody else to say. Yeah, loud.
Tom Cruise is Jackie.
Tom Cruise is Jackie. All right, good. Good. Oh, actually, no. Actually, the third one, right? The third one. You're going too fast. This third one. Try again. The third one. Ethan Hunt is Jackie. Good. Yeah. Next one. Any? Oh, you're the fan, right? Yeah, go ahead. Yeah. Oh, yes. Good. Good. All right. Tom Cruise is Jackie. That's good. All right. Next one. Last one. Yeah, maybe someone at the back. Yes. Jackie is Tom Cruise. Am I right? Jackie is Tom Cruise. Jackie is Tom Cruise. Yes. Seems like we got a consensus, right? Good. All right. All right. Anyway, just for fun. Okay, guys, any question about this example here? So basically, my point is aliasing can be very much tricky, but at the same time fun. So you want to really trace a program like this way, right? So don't be too surprised if I give you something similar in the test. Okay? Any questions about this? Before I go to the more boring one. Okay? You guys are a little bit calm today. When I last time taught this example here in South Korea, I simply replaced Tom Cruise by some very famous star. Yeah, but the class actually went crazy, right? Yeah. Anyway, that's okay. You guys are very, how to say, very mature. How about that? Okay. Okay, let's now go to the second example. Huh? Yeah, we'll do that later. We have to. Okay. Okay, let's now go to the more serious example over here, which I will also like to go through. Oh, by the way, for this source code over here, I actually got, I will also post it for you to play with, okay? Simply play with maybe just replace Jackie by yourself. You can have fun, okay? And replace whatever star you might be favorite about, okay? Okay, let me just conclude about aliasing here, like a mini conclusion. Whenever an object at the runtime may have more than one identities by using assignment to copy the addresses. And also, calling a method on one of the names is effective to all the other names, right? That's basically what we are trying to illustrate so far. So now, let me go to the little bit more challenging example here. We'll do it together again, okay? Okay, so there are actually two versions of the example here. One version you have seen already before. This one is very easy. So let me just go to the harder one directly so we can just focus more. Okay, so now what we'll do is, okay, there's something very similar to your 1022, but I modified it a little bit. So let's do it together. Let's treat it as a brand new example. Again, get a fresh paper, and then we'll do it together. Okay, this one has something to do with array and modulo. You guys remember what the percentage sign means, right, in Java? In case you have forgotten, we'll review, okay? It's also nice to review. Okay, so now, this one is gonna be, just draw, okay, the first four lines, we got Alan, Mark, Tom, and Jim. These four, okay? Can we draw it all together, okay? So now, assuming that, okay, now each person has name and age. Not weights, name and age, okay? Two attributes, that's the assumption we are making. Apparently, think about how many objects you should draw. Think about it. It's very easy to judge, just see how many new keywords you have. Yeah, take your time. I'm also drawing, so we can just compare. So you don't have to just watch me drawing. Oh, let's assume only name and age, only these two. Let's assume. It's a different example, but you will get the idea. There's no weight, just name and age. Okay, let's say another 20 seconds. I'm almost done from my side. And again, you want to be as precise as possible so you can actually read the diagram you're drawing. So you'll be useful for your tracing. Okay, shall we compare? 4 objects, right? Alan, Mark, Tom, and Jim. And at the moment, let's say age is simply default, just 0. Okay, let's say the constructor there simply initializes the name. Alan, Mark, Tom, and Jim. Okay, we got 4 objects here. At the moment, is there any aliasing? No. Okay, each object here nicely just has one particular variable storing its address. At the moment, there's no aliasing. Okay, nice and clean. But things will get a little more ugly. We'll see. Now, okay, this guy here, let's try to read it first, okay? Could you please read this line? I'm going to put it on the iPad, and I'll show you exactly how it should look like and how you can analyze that line. It's also important to note. Okay, so now let me swap to iPad here. So that's the line. Can at least somebody can try to explain to me what this line is trying to do? At least try. Ladies, can we just have you try? Yes, you. Try. You want to try? Yeah, you want to try? Are you in this course? Yeah, you want to try to explain to us what that line is supposed to do? Addresses, so the array is going to be of size 3. Okay, so now this line here, first of all, you should really realize how to read the type of the variables over here. Over here, you can see that person square brackets. That means we're declaring an array, and then each element in the array is of type person. So that means each element in the array stores the address of some person objects. That's how you read it. And then we call the array name persons1. And now this is so-called initializer expression. Okay, initializer. Let me just, in case you forgot, it's called initializer. And then we're trying to initialize the array to be size 3 because you got exactly 3 elements here. And each element is simply going to store the address of some person objects. And the first element of the array is going to somehow copy the address that is already stored in Alan. Just make a copy. That's how we get aliasing. And the second element is going to copy the address stored in Mark. And the third element is going to copy the address stored in Tom. So now you can think about its equivalent to say the following 4 lines. Okay? Now, so this is completely equivalent to the following. We say persons array and persons1 is assigned to new person, and now we have to give a size, right? So now we know 1, 2, and 3. So put 3 here, right? And now we're going to assign the slots individually, right? That's what the initializer will do. So we can say persons1 at position start with 0, right? Somebody pointed 1. Okay, be careful, 0. You meant the first position, which is of index 0. Okay, 0 is assigned to Alan. Okay, and then can I just be a little bit lazy here? Persons1 at position 1 here is assigned to Mark, and then persons at position 2 is assigned to Tom. Okay, clear? Good. So now, let's see how we can, I would say it doesn't really matter if you think the blue way or the green way, doesn't matter, but you just have to know their equivalents. Okay? The blue way is very convenient because you can save by writing 4 lines. You can just write in 1 line. Okay? But they're equivalent. So now let's see how we can visualize this. So I'm going to use green here. I'm going to use the green one to show you the step-by-step. First of all, we're going to create an array of size 3. And the array is going to store, each one of them is going to store the address of some person object, right? And also you can see the persons 1 is actually the name of the array, but now array itself is also like an object array, right? Just like an object. So that means persons 1 stores the address of the starting point of the array. That's how you draw. Okay? And then we say that, so now help me out over here. Let me just show you one in detail. When I say persons 1 at position 0 is assigned to Alan, how should I draw it? Let me ask you first. What I used to see students draw, I can see what they meant, but is this really correct? They draw something like that. Does that make sense to you? Not really, right? Let's think about, let's be very precise to justify why this notation, even though I can see what you're trying to say, but it's not really right. Yes, go ahead. I agree, but what's the problem with this one here? Let's learn from mistake. Why is this one not so correct? Think about this. The way we use arrow is by saying the starting point of the arrow is some placeholder for some address, the starting points. And the end point should be some objects, right? But now we kind of go the opposite way, right? You can see the starting point for this pink arrow over here is actually an object, not really like a placeholder of the address, right? So it's completely the opposite way. Okay, that's why it is not good. Okay, we're scientists, so we want to be very consistent with our notation. So this is not right. So what you should have drawn would be something like that. So that means the slot at index 0 storing some address is going to store the same address as what Alan is storing. So that's why we have the 2 arrows pointing there. So now, up to this point, do we have aliasing? Yes, you say yes. So now tell me how aliasing occurs.
If we want to refer to Alan,
Mm-hmm.
the object, we could do so by going in the 0 index of persons 1.
Uh-huh. Or
Alan.
Alan. Exactly correct. So we do have aliasing at the moment. Let me just write it down for you. So if you have aliasing, that means you can try to refer to the same objects in different ways. So now over here, let's say this. Let me put it here, aliasing. That's exactly correct. Very good. Okay, so you can see Alan is referring to this object here. Is there any other expression, path expression, referring to it? Indeed. I can say persons 1, which is the array, and then at position 0, which is storing this address over here, is the same as Alan, right? So it's also referring to the same address. So they are the same. So now you can try in Eclipse, if you try to say Alan equals persons 1 at position 0, it should be true, right? The same address. Okay, again, it's a review. Okay, let's complete the rest. So we're going to say the persons 1 is assigned to Mark, like that, and persons 2 is assigned to Tom. You can see we also got aliasing for the other 2 objects, but for the Jim object, there's no aliasing just yet. Okay. Okay, any questions about this? Things get a little bit more complicated when we get loop and modulo operation, right? That's why it's worth going through this example line by line. Okay, let's now see what we should do. Okay, now persons 2. Persons 2 is assigned to new person with the size persons 1 dot length. Can you draw it, please? I will draw it as well. And now it is more important for you to think about, after executing this line, what should be the values for each element in the array for persons 2. Think about it, okay, and try to draw it. Okay, I'll try to draw it as well. Okay, done? That should be something you should draw. Basically, persons to array is pointing to some array of size 3. But now initially, unlike the initializer line, so we are not assigning any addresses yet to any of the elements. So that means every one of them should be pointing to null. I would say putting null here is kind of optional, but it's just for my preference. It's more explicit about what's going on here. Of course, as soon as you assign any of the elements to be some address, you'll become not null, right? We should draw some arrow instead. Okay. Good. Let's go back there. Now let's try to see what this line will do, right? This is slightly different from what you saw in 1022. I make it a little bit more complicated for you. Okay, so it's worth trying. Now, let's see, let's get a big picture here for 7 and 8. For line number 7, we're saying that we're gonna go for a loop starting from, if you are not really comfortable with having a for loop, please refer to the background studies. If you got trouble, let me know. I'm just assuming that you're okay with the loops. Line number 7, starting from index 0, and then until what's gonna be the final value for I in the iteration? 2, right? In this case, yeah, because there'll be persons.length minus 1, right? Okay, and then I++. Okay, now, and then line number 8, we have persons 2 at position I, depending on what I is in the current iteration, is assigned to persons 1 at a particular index, and that index is calculated using the modulo operation. And the way I do it is simply is I plus 1 modulo the length of persons 1. Okay. Now, before we actually see how this, the diagram over here should be changed, let's do something as a practice to prepare you well for that. Okay. I think that'll be a nice review for the modular operation. Could you please just have a look at this one? Think about how the loop sheet is going to run. And then before I switch back to the iPad, I will make some preparation on the iPad, and then we'll go there together. Look at that line and think about yourself how that should be executed. Oh, are we running out of time? Wow, time really flies, doesn't it? Okay, guys, how about this? Give me I won't post this slide just yet. How about this? Do me a favor, copy line number 7 and 8. Okay, copy that down. And what I would like you to do before Wednesday I'll spend maybe the first 20 minutes or so to finish this example. But now, please try to see how the diagram should be updated. Okay, take a photo, yeah, that's a good idea, okay? Okay, I'll see you on Wednesday.